Welcome to all. This is first edition of the Bhumandal Talk series that we are starting under the auspices of IEEE-GRSS Bangalore section. So welcome to all. The idea of this talk series is for us to inspire, enthuse, inform citizens about various advances in engineering and science in the areas of Earth observations, remote sensing, etc. Pu means earth and mandal means sphere in Sanskrit. So we have abundant expertise in this community to for us to exploit, right? I am Jaya Srivalsan Nair. I'm a faculty member at IIIT Bangalore, and I'll be coordinating this talk series. In the first edition, we have with us Dr. PG Diwakar, who is a distinguished scientist at ISRO. And he's going to give us an exciting talk on the various initiatives that ISRO has undertaken in the national interest. And before that, we'll have Professor B.S. Dayasagar, who is the founding chairman of this section. He will, of this chapter, he will give an introduction to the speaker. So the speaker for the day has also requested us that we should use the chat box for questions and comments, and he'll be very happy to take them at the end of the talk. So yeah, so that's it from me. Off to Professor Dayasagar. And thank you all for coming. It's a Friday evening and all that. So we'll hope this talk series will take off really good. Yeah. Thank you so much. Yeah. Bye.
Diwakar, and we are all very delighted to have you as the first ever speaker of Bhumandal Talk series. And thank you very much, sir, for accepting in a short notice. And for the participants to introduce Dr. Diwakar. Diwakar is a well-known personality in Indian remote sensing community. And I know he held very important positions like Scientific Secretary of Indian Space Research Organization. And before that, he was also the Deputy Director of National Remote Sensing Service Center. And and he had his PhD from National Institute of Technology, Surathkal. And he has many awards. And some of them are like National Gold Award for Innovative Usage of Technology and E-Governance, and the Globe Forum Award, Globe Sustainability Research Award from Stockholm, Sweden, and many merit awards from Indian Space Research Organization, and most notably National Geospatial Award from Indian Society of Geomatics. And he has also been conferred Award for Space Science and Applications, and Bhaskara Award of 2018. And he has been a fellow of Indian Society of Remote Sensing. And as you all know that acquiring data is one major part via various different sensing mechanisms. But once the data is acquired, and mostly the pre-processing and post-processing facilitate to the users, specific data to the users, is a Herculean task. And that is where I could see Dr. Diwakar has contributed significantly. And it is indeed a great achievement that the Bhumandal, not sorry, and Bhuvan portal, and I have been seeing almost for the last more than a decade, and Bhuvan portal has been highly user friendly to actually choose the data and then purchase the data, or to acquire. There's a lot of data which is available free of cost, and so that is where actually Dr. Diwakar has contributed significantly, and I believe we would be learning much more than what we actually know from his talk on Earth observation and geospatial applications and Indian experience. And let us listen to Dr. Diwakar, and we welcome you, Dr. Diwakar sir, and you can start your talk. And just before that, and let me uh, talk a few words about Professor Jaya Nair, and he is very instrumental in bringing that Bhumandal Talk series. This is the first ever talk, and I know it is there is a lot of hard work behind that to invite eminent people like Dr. Diwakar, and he could really do a tremendous job. And I hope that this series would go
Thank you so
every month. And so let us welcome Dr. Diwakar.
much.
Very good evening, and thanks to Dr. Dayasagar.
Yes.
Thanks to Dr. Jaya for uh, consistently going behind me and trying to get me into this presentation in the evening today. Extremely thankful to the IEEE Bangalore chapter, GRSS, and of course to Jaya and Dr. Dayasagar and the entire team. And absolutely happy to be addressing a whole lot of people who are joining in for this particular talk. The focus of the talk is the Earth observation and its applications, particularly the Indian experience, as part of the book bundle talk series. So what I'll do is I will take you through a set of slides which will showcase the various applications that are being uh, provided to the Indian government, be it at the central level, be it at the state level, or even at the local level. I will try to see to that I'll finish my talk in about 45 minutes from now. Uh, Depending on how much I elaborate, I may possibly exceed by about 5 minutes, but I'll try to control. Uh, you are seeing a globe in front of you, I hope, and there is a small animation where you see polar orbiting satellites around it. Most of my talk will be on these satellites and what they view when they go around the globe, particularly when it the kind of data that it provides and how we utilize that particular data for various activities down on the ground with respect to land, water, and atmosphere. That's the main focus. And of course, it's not that you need to be doing polar orbiting satellite imaging. You can do imaging from the geostationary orbits also, and we use it for varieties of other things, which I'll be telling towards the later part of my talk. Some of these are the Earth observation satellites which we are using today. If you are able to see the Earth observation satellites, what I have put in front of you, in India we are simple, and the Indians are simple. So our naming of the satellites is also very simple. So we say resource sat for land and water. We use Cartosat for mapping. Carto means maps anyway, and OceanSat is named after ocean. And of course, we have INSAT series of satellites for weather and climate. Of course, in addition to the OceanSat, we also have the scatterometer, which gives us the wind vector information on the surface of the ocean. And of course, SARAL is the altimeter data, which is a joint mission with the French space agency. Uh, we have been using these satellites. Of course, there have been many other satellites earlier. Right now, I'm not showing. I'm just showing you those satellites which are live, available, and providing data for us to do the various remote sensing related activities on the ground. ISRO has mastered some of these typical technologies, like simple push broom cameras, which are being used right from 1988 when we became operational remote sensing agency. We started using it. Basically, it uses the charge coupled devices. No longer it uses any mechanical system, and we are able to do the push broom imaging pretty well, and you are able to get arrays of data sets, basically energy reflect from the surface of the earth, which is captured in the form of detectors on the detectors and converted into digital data. Similarly, if you look at the three-tier imaging system, this is a very unique thing which has been done by India as part of the resource sat series of satellites. Presently, we have resource sat 2 and 2A, and very soon you'll be seeing 3 also. The beauty of this particular satellite is that uh, it has three types of cameras, and it does three types of imaging. One covering a very large area, 740 kilometers Swath. Other one covers, list 3 covers something like 141 kilometers Swath, while we have a 5.8 meter resolution, 30 kilometers Swath covering list 4 camera. This has become a darling of the world in the sense, I would say, because Many of the other countries uh, have been using this particular satellite data. Even today, we provide this data to US and Brazil for monitoring of their resources. ISRO has also mastered the three-dimensional imaging capability. We call it as stereo imaging capability, which you see in the center here. And this particular capability allowed us to make a Cartosat-1 satellite, which lived for about 15 years and provided excellent data for the entire globe, particularly the digital elevation model with a pixel size of 2.5 meter and a vertical accuracy of about 7 to 8 meters. You can see a typical picture of a three-dimensional area around Himalayas being shown here. And on the right-hand side bottom, you see the radar imaging capability, which ISRO has demonstrated through RESAT-1. Radar imaging is a very unique imaging capability where you can penetrate the clouds, particularly in the current season. When you want to see the crops, when you want to see the disasters occurring, this will be the best you will be able to see. And we have an excellent imaging capability with respect to ScanSAR, strip map, and also spotlight, wherein the resolutions can vary from 25 meter to even 1 meter. Um, India is again having a very unique position with respect to hyperspectral imaging. A very recently, we launched a hyperspectral imaging camera, which has more than 300 spectral bands. This gives you wealth of data when it passes over any particular portion of the Earth. And once you have calibrated your satellite well, the distinguishing capability of this particular satellite on agricultural crops, on geology, on various other features on the Earth is something marvelous. So India today is utilizing the hyperspectral imaging capability for understanding better geology or better agricultural crop discrimination and things like that. Typically, if you can see this, what's going on in front of you, the various data products that we provide to the user community is being showcased to you. There are fusion techniques possible. That means you can fuse a panchromatic 1 meter or below 1 meter data with a multispectral data. On the left hand side, you're able to see, you can see excellent features. On the top, you're able to see almost a three-dimensional resource sat picture, and at the bottom, you can see the Cartosat imaging capability, which gives you the three-dimensional imaging capability. So the Cartosat, the resource sat, and the fusion techniques allows us to do the kind of data processing which is required for enabling the users to get the data and to utilize it for various resources purposes. Similarly, if you look at the other capability from the OceanSat and also the scatterometer, you can see on the right-hand side top the scatterometer wind vector data, which allows us to understand the cyclonic storms in a much better way, because the wind vector data allows us to make better analytics with respect to the winds. On the right bottom, you are able to see the hyperspectral imaging capability, which is being shown to you, wherein multiple bands are simultaneously being analyzed on the terminal. On the left-hand side image, of course, it is the advantage of atmospheric reflectance correction, which enables you to see the data much better. So I'm just giving you a glimpse of the kind of image processing what we do at ISRO before we provide the satellite data sets to the user. A typical example of wide swath imaging. You can see almost the entire northeast and part of the eastern part of the country, where you see the wide swath covering 740 kilometers image in one go, and you are able to literally use this kind of a satellite data to cover the entire country in about 4 to 5 days. So this is from the advanced wide field sensor. What you're able to see, you can see the beautiful Himalayan vegetation. You can see the Sundarban area. In fact, I can take you into the Sundarban area. You can see the very unique mangrove forest that exists there. So it is possible for you to get to that kind of a resolution where you are able to differentiate 50 meter or 50 meter by 50 meter or 55 meter by 55 meter pixel, and you can analyze varieties of things. So if you want to see the dynamic events happening on in the country, this would be the best satellite to view. And we have been using this particular satellite data very effectively for varieties of things. I'm going to show you some of these applications very soon. The first application which I would like to put in front of you is the temporal imaging capability, which allows us to get the land use land cover pattern. On the left hand side, you are able to see the annual land use land cover map. In fact, we have been doing it for the past 15 years. That means 2004 to now, you will be able to see a time series of land use land cover map of the entire country, which gives you the agriculture, the forest, the urban, the water bodies, and various other things. Of course, you can the Himalayan cold desert, you can see the Rajasthan desert area, and of course the entire agriculture and forest area very clearly. And of course, this is a small patch of Haryana. It shows in two-time frame how the urbanization changes are happening. Of course, you can view this particular data live on Bhuvan. I'll show you at the end how it is. On the right hand side, you see the wasteland maps. These wasteland maps are very important. We have been doing it almost every 3 to 5 years, and we have already done about 5 to 6 times the wasteland maps. And government uses this particular data to plan for developmental activities in the country, like watershed development program uses this data very effectively. Down the line, I'll be showing you some typical examples of how we are doing the watershed management in the country. So the wasteland maps are used by the Rural Development Ministry for utilizing it for example, to understand how to locate new industrial towns and things like that. Of course, here is an example where I have used the land use land cover map of the entire country. I am able to extract the Kharif season data and the Rabi season data, and of course the Jharkhand image is also being shown to you on the right top. Right bottom. Basically, the left-hand side image, I'm calling it as a multi-season annual cropping. That means every month we have a composite data of the AWIPS camera image that is made available, and we keep compositing that for the entire year. End of the year, you're able to see a crystal clear land use land cover map for the entire country. So that's the beauty of the AWIPS camera, that is the advanced wide field camera, which allows us to get the land use land cover to this kind of details, where Kharif crop, Rabi crop, the Zaid crop, that is the summer crop, double cropping area, current fallow, plantations, evergreen forests, etc., are able to easily be discerned from this. So you can extract the Kharif, Rabi, and summer crop data, and that will be of great use to the country for understanding the dynamics of the cropping systems in the country. This is an example where identify a piece of land to put a solar farm on this particular side. You're able to see on the top, it is not there. On the bottom, you're able to see the pins. You use the wasteland data to locate new features, and typically you are able to get a huge area for solar farm. On the right hand side, identification of an industry. So wastelands can be utilized for identifying industrial areas or solar farm, that is for energy generation and various other developmental activity, because you're not able to do much with the wastelands. You're not able to use it for developmental purposes. Similarly, when you look at the cropping system in the country, we have been able to operationally come out with agricultural crop production estimation and yield estimation for the country. That means Ministry of Agriculture uses this data for providing the crop information. In fact, they get the crop information 1 month in advance of the harvest. You can imagine the advantage of this kind of data. Because of the satellite data, if you are able to get 1 month in advance harvest information, the country can make its complete plan for how they are going to utilize the produce across the country. It could be wheat, it could be rice, it could be various other major crops. In fact, we are doing it for about 8 to 11 crops in the country, and we plan to exceed more and more number of crops in addition to the horticultural crops. So advanced information with respect to the availability, the acreage and production of crop allows you to decide on import or export, and also allows you to do the planning with respect to distribution of food grains in the country. And that's what is the advantage of using it by the Ministry of Agriculture today. And in fact, we have set up Mahalnabis National Crop Forecast Center, which utilizes this entire data in the country. In fact, satellite remote sensing based cropping system analysis and advanced cropping system analysis is being done by MNCFC, what we call. We have also worked very closely with CWC, that is the Water Resources Ministry, which has been utilizing the remote sensing data for major hydrological projects in the country. In addition to that, the entire river system in the country has been mapped out, and they have an excellent data. We call it as India Water Resources Information System. It is called, popularly called as India WARIS. It has surface water, groundwater, hydromet information, water quality information, snow cover, snow cover runoff, glacier, you can name them. In fact, 12 major layers, but there are many other layers which allows them to understand the water system in the country, and water is going to be very, very important for India and the whole world. So in fact, if you go to this particular site, it's also possible for you to get the entire information with respect to River Basin Atlas of the India. In fact, we have transferred this entire system to the Water Resources Ministry, and they are setting up National Water Informatics Center very soon. The Water Informatics Center will be integrated and put out in the public domain, wherein all this particular data will be available. So the advantage here is that you are able to address the water related parameters in a big way, and the CWC uses it on the part of the Water Resources Ministry in a very effective manner for management of water in the country. In addition to that, we are presently working on National Hydrology Project, wherein we look at the snow melt forecast, the soil moisture, evapotranspiration, and various other hydrological parameters, including the hydrological drought. So hydroinformatics products are going to be important here, which you are able to see very clearly. The entire Himalayan range is going to be seen for the snow melt runoff or the snow melt forecast, the glaciers, and of course the GLOF, what we call. These are the very important aspects which we are seeing here, in addition to the country level surface runoff as well as evapotranspiration information, which becomes very, very important. These are some of the databases which are being now prepared for the Water Resources Ministry, and we are validating it, and very soon these data sets will be made operationally available for Water Resources Ministry to utilize it for varieties of modeling schemes and planning aspects. The beauty of the Indian remote sensing satellite is that it can provide to you the status of water bodies in the entire country on a, 5-day basis or a 2-weekly basis, depending on the requirement. What you're able to see in this particular map is major reservoirs or even minor water bodies. You are able to see it very efficiently, and you can monitor smallest of the water body, something like 2.5 hectare water body can be seen from space, and we can monitor it literally. That means every 50 days we keep on refreshing this database on Bhuvan, and anybody can take a look at what's happening to my water body. The beauty and the offshoot of this kind of a data, what we have been able to make available, is that Telangana government is able to use it for water resources information system. In fact, they are able to manage basins accurately. They are able to bring out their minor irrigation system, major and medium irrigation system. And this Telangana Varis is a very unique example of how every drop of water can be effectively utilized for small irrigation or medium irrigation or even major irrigation system. That means basically water equivalent cropping can be easily practiced, and they have made a dashboard, and this dashboard feeds all our data. In fact, they have geotagged more than 45,000 water bodies in the entire state of Telangana, and literally you can say the water managers in the state have water resources information in their hand. That's the beauty of this information system. You can see the cadastral data which has been superimposed, which means that survey number wise water availability, survey number wise the kind of crops one can grow, survey number wise the kind of dynamics what you can utilize here. You can see here the survey number wise database very clearly shown. We have done it for major portion of Telangana. The work in progress is that we work very closely with them, and this entire team has understood the nuances of using online GIS, and they're able to create their own data. They're able to manage their own water resources very, very effectively. Looking into the groundwater here, we did a major project for the entire country. We call it as National Drinking Water Mission. We are able to provide the water potential in the entire country at 1:50,000 scale. In addition to that, we have also been able to provide the water quality maps for the whole world, for the whole country. And we have released something called as Bhuvan Bhujal Geoportal, which provides the information with respect to the geology, the geomorphology, structure and the integrated sustainable water resources information, which is being very effectively used by many states. Using this, it is possible for you to plan for your recharge structure. At the same time, you are able to see which are the areas where you have potential for water, groundwater, and you can narrow down to the area where you would like to exploit water, at the same time provide the recharge. That's the beauty of this data, and this particular data is made available to all the state governments in the country. Now, in the recent past, we had something called as Jal Shakti Abhiyan. Jal Shakti Abhiyan was a major initiative taken to see that during monsoon, we are able to recharge the groundwater so that it is effectively utilized for the rest of the time. What has happened is we collected a lot of data from our sources like soil texture, various areas where you can do with the different kinds of water conservation, which are the areas where watershed activities are going on, where you can have various structures brought in, and various other interventions. All these interventions were organized and provided. Lakhs of water bodies were done. You can see the geotagging that has been done. These are the patches what you see on the India map that very clearly shows various sources of data in addition to the ground data was used to create field assets, what we call under the Jal Shakti Ministry, wherein large number of water ponds were created and structures were created so that sustainable recharge of groundwater can take place. So from these past two slides, present and previous slides, it is very clear that you can estimate the groundwater, at the same time find out the ways and means by which you can recharge the groundwater so that you have sustainable water cycle. In the topic, we have done a lot of work on forest and the forest type mapping in the country. In fact, the biennial forest report, which the Forest Survey of India brings out, uses the satellite data very efficiently. In the early years of remote sensing itself, the Forest Survey of India understood, they worked very closely with us, they understood what is remote sensing, and they are able to map the forests on their own. Every 2 years, they bring out the status of forests in the country. Now, what we did is using the satellite data, we brought out the biodiversity map of the country. You can see one patch of Himalayan range. We have done it for the entire Western Ghats. We have done it for the eastern part of the country and entire country right now. So there is some statistics you can see on the right hand side. 125 different vegetation types, 6,000 species database, and biological richness and disturbance regimes have been created, and we are able to very clearly bring out the areas which you need to do conservation, the bioprospecting, the rare and endangered species of plants, where they are and how you need to conserve and things like that. And this has been very effectively being utilized by the Department of Biotechnology, in addition to the forest, the state forest departments, and many other forest managing systems in the country. This is a very unique database that has been created for the country, which has used varieties of space-based modeling system for providing the data to the country. This is yet another interesting story. Of course, each one is a story for me because they have been all big projects. This is how a watershed development program in Karnataka was done some time back, where we did participatory techniques using GIS, and we saw to that multi-layered GIS databases are used for every micro watershed. And about this, the people are sensitized, and we were able to come out with land and water management system so that you are able to make a sustainable watershed management system. This was very nicely adopted as part of the Sujala project, and literally the remote sensing derived maps were taught to the villagers using Rangoli diagram on the ground, so that the farmers give their inputs on the sociological and other parameters and the difficulties what they face. For example, you can see a farmer showing his particular cadastre and then telling about it, and then we map that data onto the satellite database and then take it into the satellite database, plan it, and come out with what is the most ideal condition under which they can do management of their land and water resources. And once you do it consistently for about 2 years, 3 years, the results what you see is dramatic on the ground. You can see on the left hand side a pre-image, a pre-treatment satellite data. You see a lot of gully terrains or very poorly managed terrains. For example, this edge you can see. But when you do your water and soil and land resources management better, you can see a lot of greenery coming up. You can see all the gully terrains. In fact, this particular part of the terrain you can't see, but you can see beautiful agricultural patch or plantations that has come up. Beautiful foreshore plantations they were able to grow in a very short time, and excellent forest they were able to grow, which was not there earlier. So a dramatic change of changing the soil health from what it was to what it is possible if you are able to follow a sustained agricultural pattern in a watershed development mode. This has been demonstrated, and now we are helping the Ministry of Rural Development in a similar kind of a project, watershed integrated watershed development plan with respect to soil and water conservation. And we are monitoring about 86,000 watersheds in the country today, and they exactly follow a similar methodology by which we are able to conserve the soil and water conservation from both satellite and the ground-based system. You can see the geotagging techniques which has been done to actually tag the uh, exact location where they have done a check dam, for example, in this case, so that this check dam also helps in understanding whether the check dam has been really done, the money has been really spent in the truthful way, and the kind of attributes what you get, where it is located, what its geographic coordinates, everything can be seen. For example, here there is a patch and you can see a water pond coming up. There is a patch here where beautiful biomass has come up. The photograph of that is being shown here, and a lovely water pond has come, which possibly was not there earlier. So this is how we use the GPS-based geotagging and image-based time-swapped mapping to showcase these kind of activities. Urban front, the Ministry of Housing and Urban Affairs is using very high resolution satellite data, what you see on the left hand side, to convert it into a land use land cover map, a high resolution land use land cover map. In fact, this is an image of Trishur, Kerala. And this particular data under Amrut program is being used for master plan preparation. And once you have a master plan preparation done, your planning of the cities will be much better. This government has been spending a lot of time to see that we have planned cities. Most of us know that many of our cities are not pretty well planned. We do have a lot of chaoses. Bangalore itself is a typical example for that. We know that. But future is not going to be that way if we are able to see that Amrut uses this in addition to using a master plan for preparing your base maps and then going for the master plan. Some of these master plans can also be further used for the smart city programs. So that's how these kind of data sets are being used. We are also helping the Prime Minister's housing. It's called PMA. It's under the same ministry. We have been able to tag more than 45 lakh housing programs that has been developed. What we do here is we use geotagging and imaging technique from the time the house started or not yet started, the foundation level, lintel level, roof level, and complete level. The advantage of doing this tagging is that you are able to really see that the money goes to the right direction, and the house really comes up, and you are able to see the transparency which is required in the governance. A typical example of governance mechanism that has been adapted by this ministry, wherein the Housing for All program of Prime Minister literally goes through the kind of tagging what you're seeing here, and our mobile apps have been very effectively used for geotagging all the housing program that has come up in the country. A typical example of urban growth, I thought I'll just show Bangalore. Right from 65, if you keep on seeing how Bangalore has grown, 99 data, 2007 data. So you can see the explosion of housing that has taken place. And one can easily see, in fact, we have gone beyond the kind of boundary which used to exist earlier, metropolitan boundary. If you really look at it today, the situation is something like this, where we have gone possibly much beyond the metropolitan boundary, and metropolitan boundary possibly is being reframed again and again to accommodate Bangalore the way it is growing. So urban sprawl is being effectively monitored and showcased from old time to new time, and all this data can be very effectively used to see how we have grown and in what direction we have to go. Typically, the urban dynamics is what is being showcased here, and government can very effectively use such kind of data sets. We today varieties of technology coming in. We know that artificial intelligence is very, very important. World is going complex. You need better analytics, better techniques and technologies. Big data analytics is one part. IoT technologies are another part. Distributed computing is coming into the picture. We have started using some of these, or in fact, all of these tools and technologies with our Bhuvan and other geoportals, what we have, like Vedas, and trying to bring in newer and newer scenarios so that complex problems can be easily solved through machine learning and deep learning techniques. Typically, a deep learning technique looks at the objects, looks at the pattern, and it for predictability, forecasts, and feature extraction and things like that. And we use very special segmentation algorithms to see that we are able to actual change detection that is happening on the ground. So these techniques are being very effectively used on our portal. In fact, a lot of student community may be there in this particular audience today. I would encourage you to get into this particular portal. It uses some of these techniques and it showcases huge amount of satellite data, particularly for researchers. And in fact, researchers can get onto this particular platform and do varieties of things. In fact, one of the unique things what this particular portal does is on renewable energy. My next slide is on that. We have been able to implement a national program wherein we use INSAT satellite data for computing the solar insolation. And from there, it is possible for us to bring you what is the capability of exploiting solar energy on the top of your house. This has become a very popular program, and we have been able to bring an integrated portal for Niti Aayog, which uses this data for looking at the energy sector in the country. And you can actually download this mobile app from the Vedas portal, and you will be able to test out on any target what is the situation with respect to the exploitability of the solar energy and how we can use it. I use it myself, and many people are using it. If some industrialist would like to set up a solar farm for being self-sufficient, I think this is the best portal to go for, and you can use the kind of portal what we have ideally for that. Of course, we address wind energy as well as the wave energy also in addition to the solar energy. One, I was talking about it some time back. This is a very unique portal which we inaugurated 2009, and it has gone leaps and bounds in providing a whole lot of services to the country. In fact, many people are interested in using this. We have 2D and 3D mobile tools and technologies. We address disasters. We look at the central government schemes, state government schemes, and we have large number of users who use this particular tool and technology in a very big way. You can see the numbers on the left hand side, and we are very proud to be offering this tool and technology, and we are opening up in a big way so that many people can get into Bhuvan. Bhuvan produces and provides wide varieties of data sets, wide varieties of solutions, and various other services. One typical service is how we are able to manage and monitor the projects that are being done in the entire country for the MG and REGA program. You know, this is the employment generation scheme. We are able to literally track every activity that happens on the ground. All these are the geotags what you see which has been captured from our mobile app, and of course through satellite imaging we are able to see literally what's happening on the ground. So both satellite based and geotagging based activity tagging, and we are able to see how people are getting employed at the same time. The activities are coming up. More than 4.5 crore assets we have been able to capture and put it onto the portal, and this is highly useful, particularly again for transparency with respect to the public money that is being spent, at the same time the kind of infrastructure that is building in the country in the rural area. You might have not realized that mobile is a very interesting tool. It has multiple number of sensors. We have been using accelerometer that is available to detect the condition of the road. You will not believe it. This is how it can be done. You just mount it on a car, you connect it to a tab, and you drive along the road. You will be able to do the road mapping first of all. Not only the road mapping, the accelerometer data can be used to characterize the red ones are the bad roads, the blue ones are the medium roads, and the green ones are the good roads. Qualitatively, I'm showing you, but we can characterize it quantitatively also. So the beauty is you have a track on the satellite data, you have the accelerometer data, you have the GIS data, all that gets captured in one drive. And all this is happening because we have an excellent GPS data available through the mobile app, and that is connected to your car. So this helps you in monitoring of the roads. That's the beauty. And we did it for Nasik, and Nasik, the entire metropolitan city we are trying to cover, and Nasik administration is very, very keen to use this. We can spread it across many other states in the country. In fact, we have done a different model using the same technology for Haryana also. Another example is 3D walkthrough. It is possible. In fact, recently I was reading on news that GIS need not be done only for outside, you can do it inside. So here is an example of Salarjan Museum in Hyderabad. If you want to literally understand how this museum is, especially these days when we have COVID-19 problems, you would like to visit a museum. I think Bhuvan allows you to do that because it takes you in and it shows you the various features of a particular museum, or it could be a architectural beauty of area, architectural beauty of an importance which you can see. So we have used GIS inside for a three-dimensional modeling, and this is one example. I hope you are able to see the three-dimensional animation which is running on my computer. Now we have been helping the fishermen in our country so that we are able to provide them information. They are deep into the sea. You know, the mobiles don't work after 10 kilometers from the land. For example, if you are into the boat, if you are starting from the coast, uh, maybe up to 10 kilometers, you'll be able to catch the signal. Beyond that, your SIM may not work. That is the time our tool comes into the play. This is a mobile app which has been generated, which has been given to the fishermen community. They are also provided with fish catch information. That means when they are into the deep sea, they will be able to use this map and exactly navigate themselves to the point where they can get the best fish catch, and they will be able to come back with bounty of fish. So navigation on the road, we have been seeing all of you see it when you drive on the road, but we from ISRO have tried to provide navigation in the sea because you know very well that when you are into the deep sea, you're all at sea, you don't know where you are. This is the only tool which allows you to make understand where you are and what is the situation with respect to the conditions there. For example, you will get location based information, you will be able to get maritime international boundaries also, you will know where is the fishing zone, and you will also get the weather updates, and it happens in multi languages. And these are the tools and technologies that we have developed by our own Indian industries and made available on the mobile app. And this is the app that runs on the mobiles of the fish use it very effectively. We are trying to popularize it all across the millions of people who stay in 13 states of our coastal country, coastal state. I'll cover a few slides on the disaster management before I close. I think I have already lost out of time to go fast. We have been watching the kind of disaster that is striking India right from 2013 onwards, because we started mapping them onto the toolbar. Of course, we do have 20 years of data available in our repository, but very clearly you can see certain states from these blue colored ones, which regularly get affected by cyclone or by floods, and people are always suffering. In addition to, of course, these days we see a lot of earthquake. Of course, we do remember what happened to the upper reaches of Himalayas when Kedarnath got into big floods. So this is the recent one. This is the kind of states that got affected in 2018-19. So we are able to understand that there is a typical phenomena that is around the country, and many states are getting into the problem. We use the INSAT system and scatterometer data, and we also use the ResourceSat and Cartosat imagery up to 60 centimeter imaging capability. We are able to see, you are able to see some of these beautiful structures on the right hand bottom of the screen, and also the 6-meter resolution data, which gives you the crop and the inundation area when you have. So these images are able to tell us what is really happening to us, in addition to the high-end infrastructure layer, the base layer, and also the elevation maps that we are able to produce for the entire country. That means you need to have a very good base map to understand and tell the country what is happening when a disaster strikes. So we use a couple of other portals like the MOSDAC, which is called as basically it provides the weather and ocean related information in a big way. And this could be used for all the weather predictions. Of course, this is an experimental portal which provides a lot of interesting products which can be used for weather prediction and weather modeling. And also they look at the cyclone tracking intensity. And they also have a very unique phenomena called cyclogenesis. Typically, an example of cyclogenesis is here where we are able to track. This is an example of Phylline cyclone where you are able to see the movement of the cyclone, track it, see the intensity, see and predict the landfall and the storm surge information, and exactly you are able to give the warning. IMD does it beautifully now because they have got a full grip on this particular tools and technology. All these data sets and softwares are available with them, and they are able to do an excellent job today and save millions of lives in the country. So in fact, we can say that cyclone prediction and warning system in India has come out of age, and IMD is doing a marvelous job using our technology. This is a typical example of how you can do the flood mapping. Kerala flood maps are very popularly known to all of us. How much amount of time the water stayed after flooding is the right-hand side map. On the left-hand side map, you're actually seeing the flood map. And this is a typical example of how Bhuvan shows you the map. On a daily basis, you're able to see the inundation layer on the right-hand side. On the left-hand side, you're able to see day-wise data, hourly data, or at what hour I got the data, whether I'm able to get everyday data. And that's what the flooding increased over a period of time. You can see it so beautifully on the right hand side, which animates and shows you online. In fact, you go into Bhuvan portal, you will be able to see all this data live on what really went through and how we went through this difficult times when Kerala got into the floods. We had Ampan cyclone very recently, and we were able to use the near real-time weather information system very effectively, and we were able to track the cyclone and effectively evacuate the people when it struck West Bengal and Orissa in a very massive way. And of course, it went off to the Bangladesh and other side. On the COVID-19, I just wanted to share with you one or two examples. We did a lot of work during the lockdown period. In fact, most of us worked from home, but still we were able to produce some very interesting applications like tracking the national level. Even today, you can see the tracking of what's happening in the world, what's happening in the country rather. We gave a very unique solution for hotspot monitoring in Bihar. We were able to take the vegetable market to the people in Telangana. The food for needy people, especially the migrating workers, we were able to assist in Chennai, and of course home isolation monitoring system we were also able to do it in Telangana. And during that time, because of less pollution, we were also able to measure the pollution over India, and that was the possibly the best time where pollution was minimum and images were looking beautiful. A typical example of what we did for Bihar, you can see 3-kilometer buffer, a 5-kilometer and a 7-kilometer buffer, which very clearly shows you the areas where the COVID positive patients are there and how management can be done. And you can see a slightly bigger picture of that. Once you zoom into that area, literally you can go down to the house level information and provide all the necessary assistance that is required for those people who literally have difficulties. With that, I close my presentation.
Thank you so much, Dr. Diwakar.
Thank you.
Everybody is happy
Thank you
with
very
your
much.
talk.
Oh, thank you very much. Thanks to all,
Yeah,
and it was a great
yeah.
evening. And I hope I conveyed what I wanted to convey, and everybody could get clarifications. Thank you
Yes,
all very
yes.
much. Thank you.